Hi everyone. I'm going to talk to you about how I built a Go debugger using sort of an interesting approach using source rewriting. So on Monday we had, or Wednesday I guess, we had a great talk from Derek Parker about Delve, which is another Go debugger. And he told this story about using GDB in front of tens of people at a meetup group and having it crash and burn in front of him. And I had exactly the same experience running GDB myself, and came to the same conclusion as Derek that we really need a Go-centric debugger, or as I like the way he put it, GDB must die. So let's put this on the screen here. So I reached this conclusion that Go needed a good debugger. I could maybe write one, but I knew that writing one was really hard. Rob Pike put it nicely in the mailing list one time. All that stands in the way is the writing of a lot of non-portable, low-level code talking to buggy, undocumented interfaces. And to Derek's credit, he's done exactly that. But when I was working on, or when I was thinking about this, I was like, there's got to be an easier way. So Go 1.4 had just come out. And Go 1.4 gave us Go generate. So I'd been thinking about using code generation in Go, and I'd been experimenting some with the AST library in Go. I'd tried to make a request tracing code generation for one of my programs. That one didn't get anywhere, but as I was thinking about the debugger, I was like, could I implement this debugging behavior by using code generation and inserting all of the debugging code I need into the program I'm debugging? And so, spoiler alert, the answer is yes. It, in fact, works, and it works quite nicely. So I'm going to talk a little bit about what you need to do to implement a debugger using code generation. And as a really gross oversimplification, there are only two things that a debugger needs to do. First, you need to be able to stop the program at any line. And second, you need to be able to print variables. So let's start with the second one first, printing variables. Somewhere in my program, I have some variable named x. It's an integer, and when I'm at the debugger prompt, I want to be able to just type print x and see its value. So how is my CodeGen-based debugger going to be able to figure out what x means? So using CodeGen, there's a pretty simple solution. I just have some mapping, which is a map of string to interface. And anywhere I see a variable declaration in the source code, I just insert this line afterwards that stores its name and its value. And then I can access it at runtime. Great. So how about the first behavior, stopping the program at any line? So here's an example line that I might want to stop at. And for every line, I need to be able to stop. So for this function println, I'm just going to insert a simple check before the line, and then do this for every single line, insert the simple check. And what the check does is basically checks whether we should pause. There are some things we need to consider, like which Go routine is currently running. Are we at a breakpoint? Are we stepping? Are we nexting? And if we should pause the program, then we output a debug prompt, and we use our variable mapping from earlier to figure out what to print when people try to inspect the state. And that's roughly all that it takes. And to show you what you can do with that, I'm going to give you a live demo right now of all of this in action. So how does this show up on the screen? OK, maybe I can even make it a little smaller. All right, so here's a really simple program I wrote when I was testing the debugger. We've got this multiplication, which is implemented in terms of doing a bunch of additions. And so if we debug it, well, first I want to show you something, which is I insert this breakpoint line to let the debugger know where to break. And I sort of modeled this behavior after the Python debugger, which I really love the experience of using that, where there's a place that you want to start debugging, so you just insert this line, import pdb, pdb.setTrace, and you're good to go. And just run it, and it'll stop where you need it to. So same thing here. I do go debug run, and then I give the program. And so what it's going to do is it takes the source code, instruments it, inserting all these line and variable declaration and other calls, saves it to a temporary file, compiles it, and then runs it. And so now I'm inside the program, and I can do my normal debugger things. I can go next. I can step into a function. I can go down into this loop. I can print variables. I can run the loop a couple times and see how the variables change. And that's it. And then a cool new thing that I was able to hack together just today, which I'm super excited about, is also doing expression evaluation. So here's a sample program that has, like, I don't know, lots of random stuff. I'm at a breakpoint. I can print f, but f is this big struct, so if I want, I can print subfields of f, and I can print as deep as I want to go. And I can even evaluate functions. So there's a +2 function in this file that returns me 2 variables. It returns the number +2, and it returns the string done. And you can evaluate all of that from inside the debugger. Super cool, really fun to work with, and makes figuring out what's going on in my program like really easy and really nice. So why use this codegen approach rather than the syscall, like, step the program sort of properly approach? One thing is, I think it's just a cool way of thinking about the problem. Like, doing code generation, you get to, like, do lots of interesting, like, several levels of thinking about the program stuff, which I find really neat. And also, a great practical benefit is you get portability out of the box. So, like, I've run this thing on Windows. You can probably run it on ARM. You can even run it in the browser. So I wrote this little demo here where you have a program running in your browser, and I'll just show you that I'm running Chrome here. And you can click the debug button, and you're now debugging code in your browser thanks to the magic of Gopher.js, which is another super cool thing. So that's it. Thank you very much.